आता आवाज येतोय का माझा?
हो.
हो. पाठीमागे आपण काय काय पाहिलं सांगा बरं?
सेकंड ऑर्डर रिएक्शन, त्याचे
बरोबर.
कॅरेक्टरिस्टिक,
बरोबर.
युनिट ऑफ K2, नेचर ऑफ
बरोबर.
ग्राफ
हम्म.
and half-life period.
Okay. Good. Nice. So, what do you mean by second order reaction? Second order reaction म्हणजे काय?
When a rate of a chemical reaction depends upon two molecules of reactant is called as a second order reaction.
Perfect. Nice. What is mean by order? Order म्हणजे काय?
It is defined as the sum of the powers to which molar concentration of reactants are raised in rate equation.
Yes. And how will you define molecularity of a reaction?
The number of reactant molecule which participate in elementary step of reaction is called as molecularity of reaction.
Good. Nice. Okay. Chan. So, today we are going to learn pseudo-molecular or pseudo-order reaction. Pseudo-molecular or pseudo-order reaction. Pseudo म्हणजे आभासी. ठीक. Definition: the chemical reaction whose order and molecularity are different is called as pseudo-molecular reaction. The chemical reaction whose order and molecularity are different is called as pseudo-molecular reactions. ज्या केमिकल रिएक्शनची ऑर्डर आणि मॉलिक्युलरिटी ह्या वेगवेगळ्या असतात अशा रिएक्शनला आपण म्हणतो pseudo molecular reaction. For example, okay, let us see the example. The hydrolysis of ethyl acetate catalyzed by an acid is given by the equation. हे प्रॅक्टिकल आपण SY मध्ये केलेलं आहे. ओके, methyl acetate किंवा ethyl acetateचं hydrolysis. So this is the ethyl acetate. It is undergoing hydrolysis in presence of acid and it gives the products such as acetic acid and ethanol. Hydrolysis means breaking the bonds of the given reactant by using the water molecules. ठीक. Ethyl acetate ह्याचा IUPAC नेम काय असेल बरं? What is IUPAC name of ethyl acetate? एथिल मेथिल इस्टर का मेथिल एथिल इस्टर्स? चॅट बॉक्स मध्ये मला नंतर पाठवा तुम्ही. Acetic acid, what is IUPAC name? Send me in chat box. Okay, its name is the ethanoic acids. So here, if we observe this reaction carefully, molecularity of this reaction is equal to 2. What is molecularity? Number of reactant molecule which participates in a given step of a reaction, given elementary reaction is called as molecularity. Here, two molecules, water and ethyl acetate, they are participating in the chemical reaction. Hence, we can call this reaction as a bimolecular reaction. Bi means two, a bimolecular reaction. Now, when we do the experiment, it is observed that rate is equal to K into concentration of ethyl acetate. K rate is equal to K into concentration of ethyl acetate. Therefore, order is equal to 1. Therefore, order is equal to 1. This is the experimentally observed quantity. So, here, if you observe carefully, we have molecularity is equal to 2 and order is equal to 1. So, both are different. Both are not the same. So, such kind of reaction is called as pseudo-molecular reaction or pseudo-order reaction. Since order is an experimental quantity, it is observed that rate of reaction of hydrolysis of ester depends upon single molecule of reactant of ester. So, in above equation, it is found that order and molecularity are different. Hence, such reactions are called as pseudo-molecular reaction or pseudo-order reaction. आलं लक्षामध्ये? ज्या केमिकल रिएक्शनची ऑर्डर आणि मॉलिक्युलॅरिटी ह्या दोन वेगवेगळ्या असतात अशा रिएक्शनला आपण काय म्हणतो? Pseudo-molecular reaction. So question is asked in exam, define pseudo-molecular reaction or pseudo-order reaction. Explain it with the help of simple example. So this is the example of pseudo-molecular reactions. Hydrolysis of ethyl acetate or methyl acetate. Its molecularity is 2, but experimentally order is observed to be 1. Okay. Now let us move to the next. Factors affecting on rate of reaction. What are the factors which affects the or which alters the rate of reaction? There are only 4 factors. First factor is temperature, particle size, third presence of catalyst, and fourth is the concentration of the reactant. So first factor, let us discuss each factor one by one. Temperature or the pressure, both are the similar. So what is the effect of temperature on rate of reaction? What is the rate of reaction? It is the rate of change of concentration of product or reactant per unit time. The rate of change of concentration of reactant or product per unit time is called as the rate of reaction. So how temperature affects the rate of reaction? When temperature increases, the rate of reaction is also increases. The rate of reaction also depends on temperature. So if you increase the temperature, rate of reaction increases. If you decrease the temperature, rate of reaction also decreases. Why? When temperature increases, the kinetic energy of the reacting molecule increases. When temperature increases, the kinetic energy of reacting molecule increases. Due to this, the collision probability of collision probability of molecules on each other increases. Hence, the rate of reaction increases. Okay. Why rate of reaction increases with increasing temperature? Because whenever temperature increases, the kinetic energy of molecule increases. Due to this, the colliding probability of molecule with each other increases. Therefore, rate of reaction also increases. It is also observed that for every 10-degree rise in temperature, the rate of reaction increases 2 to 4 times or 2 to 4 folds. Now here look at this example. Particles having less kinetic energy, okay, therefore they will move with slow speed inside a box or inside a container. Here, when you increase the temperature to the right side diagram, what happens? The kinetic energy of molecule increases. Due to this, their randomness increases, so they can collide with each other more faster than this having low kinetic energy. Okay, so when temperature of the reaction increases, the particles of reacting substance moves faster. Okay, they acquire more speed. Due to this, more collision will take place, and when more collision takes place, more chemical reaction probability increases. This causes collision frequency between reactant increases. As a result, the frequency of effective collision also increases, and hence the rate of reaction increases. So in a nutshell, we can say that whenever temperature increases, the kinetic energy of molecule increases. Due to this, the rate of reaction increases. Okay, this is the principle, and this one is important. For every 10-degree rise in temperature, the rate of reaction increases 2 to 4 folds. Now, next factor is particle size. Now, look at this diagram carefully. Observe this diagram carefully. Here, this is the reaction between acid molecule and magnesium foil. Okay, this is the magnesium foil, and this red dots represents the acid molecules. Now, in next diagram, second diagram, below diagram, this is the powder of magnesium. Okay, this is the magnesium powder. Now, if I ask you which molecule will react faster, powder form molecule of magnesium or in a foil type molecule, sheets type molecule will react faster. The reason is that when you powder down the magnesium molecules, its surface area increases. Due to this, acid molecules will react with maximum powder of the magnesium. Here, there is the less absorption of acid molecule on the surface of magnesium foil. So more surface area, more will be the chemical reaction, or more will be the rate of a chemical reaction. The acid ions can collide only with the outer atoms and not with those within a large lump or inside. Okay. जे बाहेरील जेवढी जागा असेल तेवढ्याच जागेवरती काय करतील ऍसिड मॉलिक्यूल इथे रिॲक्ट होतील. ज्यावेळेस तुम्ही मॅग्नेशियमची पावडर बनवाल त्यावेळेस काय होईल, सर्व मॉलिक्यूल्स ही पावडर ऍसिडमध्ये डिझॉल्व्ह होईल आणि सर्व मॉलिक्यूल ऍसिड सोबत रिॲक्ट करायला चालू करतील. With a powder, there are more surface particles, so there can be more successful collisions. So, in the reaction between acid and magnesium, the powder reacts faster. The powder reacts faster. The powder has reason why powder reacts faster, because the powder has a greater surface area, so there will be more successful collisions in the given time, and hence faster will be the rate of reaction. Again, look at here, magnesium foil and acid particles, same above example. When I take in beakers and if I add this magnesium foil as it is, and if I don't break down into the more small pieces, then it will go to the bottom, and there will be the large, there will be less surface area in this case. And here if I make a foil, make a powder of magnesium from its foil, then there will be the large surface area, and so in this water and acid molecule will react in extensively. When the size of solid substance that reacts is smaller, its total surface area exposed become larger. This causes collision frequency between the reactants increases. As a result, frequency of effective collision also increases, and hence increases the rate of a reaction. Next, presence of catalyst. Okay. What is a catalyst? How will you define a catalyst? Catalysts are the substances or the compounds which alters the rate of a reaction. Catalysts are the compounds or substances which alters the rate of a reaction without undergoing any change in its composition. Now look at here, this black line, there are two graphs, one with the black line and other with the red line. The black graph shows the uncatalyzed reaction taking place without presence of catalyst, in absence of catalyst. Okay, this is called as uncatalyzed reaction. Whereas this red graph is of the catalyzed reaction. This reaction is taking place in presence of a catalyst. Okay. Now डाव्या साईडला तुमचे रिएक्टंट आहेत, उजव्या साईडला काय तुमचं प्रोडक्ट्स आहे. Now look at, observe this. This is the E activation of uncatalyzed reaction, E activation of catalyzed reaction, E activation of uncatalyzed reaction, E activation of the catalyzed reaction. This is the reaction progress, and this is the potential energy or the energy of the reaction. Now, if you observe it carefully, when I add the catalyst in the reaction, its energy of activation is lowered down as compared to the energy of activation of uncatalyzed reaction. So, smaller the energy of activation, faster will be the rate of reaction. Smaller the energy of activation, faster will be the rate of reaction. Here reaction rate becomes slower because of the large energy of activation. So whenever you add this small molecule of catalyst or small molecule of catalyst, then reaction rates gets faster. Okay. Why reaction rate get faster? Because catalyst decreases energy of activation. Because catalyst decreases the energy of activation. Okay, so remember this. Why rate of reaction is increases when catalyst is added into it. Catalyst decreases the energy of activation. Okay, energy of activation म्हणजे काय? Minimum amount of energy required to the reactant molecule to gets converted into the products. Minimum amount of energy acquired by reactant molecule to get converted into the products is called as the activation energy. Is called as the activation energy. Now, next factor, last factor is the concentration of the reactant. Concentration of the reactant. How rate of reaction is dependent on the concentration. Look at the graph. Okay, rate of reaction versus substrate concentration. Rate of reaction versus the reactant concentration or the substrate concentration. When concentration is increases, here you observe that rate of reaction also increases. When concentration increases, rate of reaction is also increases. If the concentration of reactant is increased, the reactant particles becomes more crowded. Therefore, there are greater chance of particles getting collided. Hence, the rate of reaction increases. Okay, why rate of reaction increases with increase in concentration? Because when concentration of reactant is increases, the reactant particles becomes more and more crowded in a small place. More and more crowded in a small place. Due to this, there are greater number of particle collisions. Hence, the rate of reaction also increases. Okay, so these are the four factors. First factor is the temperature. Second factor is particle size or nature of reactant. Third, particle presence of catalyst, and fourth is the concentration of the reactant. Okay, when temperature increases, rate of reaction also increases. Why? Because the kinetic energy of reacting molecule increases, hence the collision increases, and therefore rate of reaction also increases. Particle size, smaller the particle, faster will be the rate of reaction. Why? Because when you go on powdering the surface or powdering the compound, if you make the small particle of the compound, then surface area is increased, and due to this reaction rate also increases. Okay, now presence of catalyst. What is the role of catalyst? Catalyst alter the rate of reaction. It decreases the energy of activation. This is the important point. What about the concentration? When concentration increases, then reactant, okay, there will be more crowding in between the reactant molecule, therefore more chances of collision is possible. Okay, due to this, rate of reaction also increases. So these are the four basic parameters which affects on the reaction rates. Now let us move to the next. Integrated rate law for third order reaction. What is third order reaction? When rate of a chemical reaction depends upon three molecules of the reactant, then such reaction is called as third order reaction. When rate of a chemical reaction depends upon three molecule of the reactant, then such reaction is called as third order reaction. Or the reaction whose order is 3 is called as third order reaction. Derivation like first order, second order. If you have understood first and second order, then you will understood this. This is very much simple. Consider a first order homogeneous reaction. A plus B plus C gives rise to product, or three molecule of reactants getting converted into the product. Now let us consider for this reaction, when time t equal to 0, concentration of reactant will be A0 and product will be 0. When time t equal to t, A is the final concentration and B is the final concentration. Now, applying law of mass action to the above reaction, we get rate of reaction at time t directly proportional to the concentration of A, B, C. Or for second reaction, rate equal to rate of reaction at time t directly proportional to A cube, or A into A. पाया समान असताना घातांकाची बेरीज होते. Therefore, rate equal to minus d upon dt equal to minus db upon dt is equal to minus dt upon dt is equal to k3 times concentration of A, B, and C respectively. Or we can write, therefore rate is equal to minus dA upon dt is equal to k3 times A cube, where k3 is called as third order rate constant. K3 is called as third order rate constant. Rearranging above equation, we get, okay, let us take A cube to the left side and dt to the right side. Let us take A cube to the left side and dt to the right side. This is equation number 1. Integrating above equation between the limit a to a0 and 0 to t, we get. Let us integrate this equation. So we get, therefore, integration a0 to a minus dA upon a cube is equal to integration 0 to t k2 dt. Now integration of 1 upon a cube dA is equal to 1 half a square. 1 upon 1 half into 1 upon a square, upper limit a upon lower limit is equal to k3 times t upon upper limit t and lower limit is 0. Put the limits. If I put the limits, upper limit minus lower limit, minus minus sign will cancel out here. Take 1 half common. So upper limit 1 upon a square minus lower limit 1 upon a0 square is equal to k3t minus 0 is equal to t. This is equation number 2. Now rearrange the equation, take t to the left side and rearrange it. K3 is equal to 1 upon 2t, 1 upon a square minus 1 upon a0 square. This is equation number 3. Remember this equation number 3. K3 is equal to 1 upon 2t, 1 upon a square minus 1 upon a0 square. Now let initial concentration of reactant a0 equal to a, concentration of product at time t is equal to x, concentration of unreacted reactant is equal to a minus x. Put this value in equation 3, we will get, therefore k3 is equal to 1 upon 2t, 1 upon a minus x square minus 1 upon a square. This is equation number 4. Okay, now let us simplify this bracket term. If we simplify this, we get 1 upon 1 upon 2t into bracket a square minus a minus x bracket square upon a minus x bracket square into a square. Simplify this bracket. If we simplify this, we will get a square minus twice ax plus x square. Take minus sign inside. What we will get? A square minus a square plus twice ax minus x square. A square minus a square cancel out. What is remaining? Twice ax minus x square. Taking x common, what we will get in next step? X into twice a minus x upon a square into a minus x bracket square. Okay, therefore k3 equal to 1 upon 2t x into twice a minus x upon a square a minus x bracket square. Okay, now take a square common, a square out of the bracket, so we get k3 is equal to 1 upon twice a square t into bracket x twice a minus x upon a minus x square. This is equation number 6, and this expression is called as third order rate equation. This equation is called as third order rate equation or integrated rate law for third order reaction. Now let us see the characteristics. First characteristic, unit. From equation 6, k3 is equal to 1 upon twice a square t into x into a minus x twice a minus x upon a minus x square. So now what is unit of this x? X is a concentration moles per liter, twice a minus x concentration moles per liter, a again moles per liter square, time unit second, a minus x bracket square. This is the concentration square moles per liter square. Okay, याचा स्क्वेअर आणि हे स्क्वेअर काय होईल तुमचं कॅन्सल आउट होईल. सो रिमेनिंग टर्म काय येईल 1 upon moles per liter bracket square into second. So therefore unit will be liter square per mole square per second. Therefore unit of K3 is equal to liter square per mole square per seconds. Next characteristic, half-life periods. What is half-life period? Time required to decrease initial concentration of reactants to its half value is called as half-life period of reaction. Expression, rate constant is given by equation 6. When x is equal to a by 2, then t equal to t half. When x is equal to a by 2, then t equal to t half. Put this value in above equation, we get equation 1 upon twice a square t half. x ची value काय? a by 2 in square bracket twice a, x ची value मांडा a by 2 upon a minus a by 2 square bracket. Okay, bracket the square. Simplify this term, upper term and lower term, we get 3 by 2 a square t half. 3 by 2 a square t half. Okay, therefore k3 is equal to 3 by 2 a square upon t half. Hence t half is equal to 3 by 2 a square into k3. So we can say that T half of third order reaction is directly inversely proportional to 1 upon A square, or inversely proportional to the square of initial concentration of the reactant. For third order, the half-life period is inversely proportional to square of initial concentration of the reactant. Now, nature of the graph. From equation 4, we get K3 is equal to 1 upon twice T, 1 upon A minus X square minus 1 upon A square. Rearrange the equation, we get 2 times K3 is equal to 1 upon A minus X square minus 1 upon A square. Now, take this term 1 upon A minus X square to the left side and twice KT3, twice TK3 to the right side. We get 1 upon A minus X bracket square is equal to 2 times K3T plus 1 upon A square. This equation is similar to the Y equal to MX plus C. This equation is similar to the Y is equal to MX plus C. If I plot this graph, I get this curve. Okay, this is the सर्वात खाली काय फिगरचं नाव लिहा plot of 1 upon A minus X square versus time T. 1 upon A minus X square time. I get straight line with positive slope. Therefore, slope equal to M is equal to 2K3T. M is equal to 2K3T. Okay, this is the graphical representation for third order reaction. Graphical representation for the third order reaction. In next lecture, we are going to see what are the different methods to determine order of a chemical reaction. Explain any one method in details. Question. This question is asked for 3 to 5 marks. So there are 4 different methods which are used to determine order of a chemical reaction. Integrated rate equation methods, second graphical method, third half-life method or fractional change method, and last differential methods. So in next lecture we are going to see this. So today's topic is over. If you have any questions, you can ask the question.